Hello, my name's Dan Barkis, and today I'm going to be introducing you to Graph, and more specifically, TigerGraph. So the first question here is, what is Graph and a graph database, and why do I care about it? So I want you to think for a minute about how we interact with things in our everyday life. Let's take, for example, a person owns a house, and that house sits off of a street, and we can see that there's kind of these relationships there. If we were to take that street, we could go outwards and we could say, okay, what are the houses on this street? We have the relationship of the houses that they are adjacent to the street. Then we can say from those houses, who owns these houses? And we can look and we can say, oh, there's a person who owns this house that is on this street. So that's kind of what Graph does, is it allows us to take these separate concepts like a person or a house or a street or a location, and it allows us to connect them to each other in a way that we can easily traverse and easily understand as people. Our brains don't separate things into different spreadsheets worth of data. We have all of this data that's interconnected in ways that make sense to us. So Graph is a way of allowing us to make sense out of our data through these connections with other pieces of data. So Graph varies from your traditional relational database in the form that your relational database is a bunch of tables. Each table kind of represents a data concept, we'll call it. So this is our person would be a table. We would have a table with our person, and that person would have some attributes under them, something like their first name, their last name, their date of birth, their email maybe. And then we would have a table for our house, house, maybe how big it is, how many floors it has, something like that. And then we would have a table for our street, just our street exists. This is its name. We'd have a table of all of the streets. And if we wanted to if we wanted to take a street and find everyone who owned a house on that street, we would have to join these tables together. We would have to take our street table, we'd have to join it with our house table, which has information about which street, and then we'd have to join that with our person table to get information on who lives on what street. And it would just be a complex process. Whereas with Graph, those edges, those traversals, those linkages between these different data concepts are already created for us by our data. Person lives in house on street. So we can say from our street, find every house that's on the street, and then from those houses, find every person who owns one of them. It's a very simple and fast process. So there are a couple different types of graph databases, but today we'll be focusing on the label property graph. This is what TigerGraph is, and it's one of the more widely used types of graph databases. As I was saying before, graphs are created from nodes and edges. Nodes are individual data points, whereas edges show the relationship between multiple different data points. In a label property graph, you can have attributes on both your nodes and edges. So what are those attributes? Those attributes are essentially the same attributes that you would have in a table, in a key value pair, in a relational database. So here, for example, we can take a payment. That payment has a unique identifier as well as an attribute describing the amount of the payment. So attributes pertain to the nodes that they are connected to. This order here also has a unique ID, and it happens to contain a quantity attribute. And then even further, our edge here, we've accepted the order, and that has an attribute telling us at what date we have accepted that order. So a label property graph is a graph that allows you to have key value pairs of attributes under both your nodes and your edges. So now that we kind of know a little bit about what graph is, let's talk about why it's useful. The concept of graph isn't anything new. In fact, one of the notable early use cases for graph was keeping track of parts within different modules and components within NASA's Apollo space program. So a graph database was used in order to relate components and their subassemblies to fuller pieces of the lunar landing module assembly or the ascent stages. Ever since then, graph has really grown in its use cases and what we expect of it. And a lot of the common use cases nowadays center around financial fraud detection, community detection within groups of people, things like Consumer 360, supply chain management for keeping track of who your suppliers are, what components they supply, what products those components go into, and managing if one supplier ceases to have a component, how does that affect everything down the supply chain, and how can you mitigate those risks? And Graph is also extremely helpful for feature enrichment for machine learning. So you can load in all of your data, you can assume these graph connections from your data, and then you can use things like label propagation in order to generate new feature sets that you can use to train a machine learning model on. You can check out some more on each one of those use cases at our website. I'll include some links below where you can see some examples of some of the great things that people have used TigerGraph for in the real world. Now let's take a look at the graph that we'll be creating. We're going to make a simple graph here just to show off how to use TigerGraph and the Graph Studio interface. So we're going to make a graph representing a basic social media application. We have 4 nodes and 5 edges that connect them. So I'll go through each one of those and explain the basics of what they include. So our first node is our person node. This is the user of our social media, and this node will contain information about our user, such as their name, their email address, when they joined, and things like that. Next, we have the post, which is a post that a user has made on the social media platform, our fake social media platform in this example. And the post will contain the content of the post, so that's some random text, as well as the hashtags that the post contains and the date that the post was created at. And then from there, we have hashtag nodes. So each one of these is a unique hashtag, and they will be tied to our posts via the hashtag edge. And then finally, we have messages, which are messages between 2 users. Those messages contain a subject, a body line, and a sent and received date time. So looking at the edges that connect our different nodes, we can see that our person is capable of posting a post as well as liking a post. These are both directional edges because our person is doing the action upon our post. In TigerGraph, we can have directed and undirected edges. Directed edges like this imply some sort of directional relationship. So this person has created or posted this post. Whereas for something like if we had an edge here linking a person to another person because they're friends, friends is a mutual relationship. So it's not necessarily a directed relationship. So person to person, a relationship is friend would be an undirected relationship because it can go both ways. Here our likes is once again directed. Our person likes the post. And we have an edge here for hashtag to represent that our post has a hashtag. And then additionally, we have edges for sent message and received message. So each message will have a sent message and a received message edge leading from the sender and then back received message edge leading back to the recipient person. This is the basics of what our graph will look like. So next we'll hop into Graph Studio and we can begin setting that all up. Now it's time to hop into TigerGraph Cloud and start building our actual graph database. So if you don't already have a tgcloud.io account, go ahead and create one. It's free. All you need is a valid email address because you will have to confirm that before you can create a solution. And if you already have a TG Cloud account, then you're good to go. So with your TG Cloud account, you have the ability to create one free tier solution at any given time. We'll go ahead and we'll create our free solution now. So we'll click the Create Solution button here. And because we're creating our graph from scratch, we'll be using the blank graph template. The current version I'm using is 3.1.1. This will just, you can select a specific version if you want, but it's best to just use the most recent version, whatever that may be. It will be defaulted to that when you go to create your solution. So on the next page, we'll see that we have the ability to select our cloud platform provider, as well as our tier, more or less, and then a region and disk size. So I'll be using the free tier, which does lock us into a 50 gig disk size and limits our partitions and replications to 1. I'll be using just AWS since that's the default, and I'm going to change my region to North Virginia just because that's closest to where I live, but realistically, any region will work for you. So on this next page is where we'll have to start actually configuring a couple things. So we'll want to give our solution a name that we'll remember. So I'm just going to call this TigerGraph 101. Tag our solution. That doesn't really matter. That's just for sorting through if you have a bunch of solutions. Initial password, it will default to TigerGraph. I'm going to just also set this one to TigerGraph just for the sake of easy login. Subdomain, this is somewhere that you will need to enter. This is a unique subdomain where your cloud solution will be hosted. This is the address that you will use to access your Graph Studio instance. So that way you can actually customize and upload data to your graph. This is also the domain that you will use if you're connecting to your graph from an external tool like our PyTigerGraph plugin or our TigerGraph CLI. So for this, I'll just use TG101. And our description, you can fill this out should you like, but there's nothing preventing you from leaving it blank as well. So we'll go to next, we'll get just a brief overview where we can confirm all of our options, and we'll click submit. So this is going to begin initializing our solution. We can see that within our tasks. This will take a couple minutes just to spin up a solution for the first time, so we'll tune back in when this is done. There we go. So it looks like our solution is now ready. So in order to access the solution, we'll click on our applications button here, and then we'll click on Graph Studio. And this will bring us to our Graph Studio UI page. We'll see there that it automatically logged me in just because it has my password saved as TigerGraph, so it will automatically log me into any solutions, but there you will need to enter any password that you may have set during the graph creation step. There's a lot to unpack here, so we'll kind of go through these menus step by step, and we'll walk through what they do and how you can use each one of them to better build out your graph. So there's a couple things to note here. First is that we are in our global view. So you can have many subgraphs within your graph instance, and those subgraphs can share vertex types from your global graph. So for example, if you had a large set of data and you wanted it all to be in one graph, but if you were doing some specific work and you didn't really want to deal with the rest of the data, you could create a subgraph that just has a certain subset of your nodes and edges within it, so that way you could work within that subgraph. These subgraphs can also be used for data access management, so you could allow certain users to only query certain subgraphs if the broader graph as a whole has some data that you don't want that user seeing. So if we click on this, we can see that we have no additional graph. So we'll go ahead and we will create a graph that we will build our solution off of. So we will just call this TigerGraph 101. And here is where we would select if we had any global vertex or edge types that we would want to include. We would select them from here. Because we haven't created any yet, we do not have any of those edge types. And we cannot have a space in our name, so I'll put a underscore. There we go. We'll go ahead and create that. That will take just a second, and then we'll see that our global view up here will switch over to our TigerGraph underscore 101 graph. There we go. So our graph was created. We can see now that it says TigerGraph underscore 101 as our graph, and we have the ability to switch back to our global view should we wish. So our next step naturally is to design our schema. We have our graph in place. Now what type of data are we going to put into it? So through this interface here, let me make that a little bigger. So through the Graph Studio interface here, we can go ahead and create nodes and edges that connect them. The important thing to remember here is that this is our schema. This is the schema that the graph will follow. We are not creating any actual data right now. We will later load in our data, and that loading process will massage it into the format of our schema. And you'll be able to see more of what I'm talking about when we actually do that process. First thing we'll want to do is click this plus up here to create a vertex type. And the first vertex that we will create will be our person. So if you remember our schema from before, we had people, messages, posts, and hashtags as our vertex types. We also have some attributes within them that we'll keep track of, so I'm going to add those as well. So the first thing that we'll notice here is that we have our primary ID. Every vertex needs to have its own unique primary ID. Something that is helpful, though, is to store that ID as an attribute. So you'll want to check this box. Without that box checked, this attribute will not be available to access as an attribute through your queries. So let's add some of our other attributes. For our person, we have an email address. So we'll call it email address. And that is a string. So we'll select string from here. We also have a username, which is also a string. We have a name, full name, once again, a string. And lastly, we have a join date, which is a date time. So there we go. We've added all of these attributes to our vertex. And if we click add, now when we hover over our person, we can see that we have their primary ID, their email address, their username, their full name, and their join date. And with each one of those, the corresponding data type. So I'm going to go ahead and just create the nodes for the rest of our data fields. And And then from there, we can build some edges. So now, next we have a post, which has an ID, and we'll keep that as an attribute as well. Our attribute name will be content. So this will be the text body of that post. So it is a string. We also have the posted date. Once again, this will be a date time. And lastly, we have a deleted flag. And this is a Boolean. So with all of these default values, they each have a default value, and you can view those default values within the TigerGraph documentation. There will be a link to that in this video description, which will tell you what they are, but you can also set your own unique default value. So you could just type in something here. So if I wanted anything where it didn't have the body, if I wanted that to be represented by, the character a star, I could put that in here. For this case though, I'm just going to leave all of these as default. And we'll just add in that now, our post, and then we have our messages, and that will once again have its ID as an attribute, and our message has the attributes subject, string, body, string, and that's it. So we can now store that as a message, and lastly, we need our hashtags. So we'll call that hashtag as attribute. One of the things that we can do with our hashtag attribute, because really there isn't any additional information within a hashtag that we need other than just what that tag is, we can use that tag as our primary ID. So we will not add any attributes because our tag will be stored within that primary ID. So we can even call it tag if we wanted. And we'll have that as an attribute. So that way, when we're querying our hashtags, we can just say hashtag.tag, and we'll be able to get the name of that hashtag. You'll see a bit more once we get into the data loading process. These things will start to click a little bit more when you can see that interface and how we map our data to each one of these nodes. So here we have it. These are our 4 nodes. So let's build some edges between them so that way they can start making some sense. The first thing we will want to do is make an edge for creating a post. So person, source vertex type, target vertex type is post, and our edge name will be posted. This is a directed edge since it is going from person to post. The person is creating the post, so therefore is a direction in the action. Now what you'll notice is that when we select directed, we also get this option here, reverse edge. Because our edge is directed, it means that we can only traverse it in one direction. So person, posted message. If I wanted to go from a post to figure out the person who posted it, I couldn't do that without a reverse edge, since we can only navigate that edge in its direction. So what we do here is we create a reverse edge. So now when I have a post and I want to figure out who posted it, I say post, reverse posted person, and that will get me the person that posted this post. All right, and additionally, we will have some attributes that we want to add to our edge. So for example, here we want the post time. So we'll have posted at, and that is a date time. So we can create that. So now we have an edge here, person posted post, and we can now go, let's create one linking our posts to their hashtags. So here, once again, we'll set our edge name, we'll set that as hashtag, post hashtag. This one doesn't need any attributes since we're just directly linking a post to a hashtag. There isn't really any additional information that we're storing there, and we will make that one directed as well. So we can add that. If we move this around, we can see our connections already. The next thing that we'll want to look at are our messages. We will have person sent message. And this will be directed. This is for our person sending a message. So this will link a person to the message that they sent. Our sent message edge will have 2 attributes. The first one will be the person that we're actually sending the message to. So the thing to note here is because this is coming from a person and going to a message, we would have to make another traversal from message back to whoever our recipient is in order to get the data for who that recipient is. So just by storing our toUser along this edge, we only need to make one traversal and we can see who that message was getting sent to rather than having to traverse another edge from the message back to that user. So this is a string because all of our user IDs are strings. And then lastly, we'll also have a sent time. So this is just the time that the message was sent at, and this will be a date time. All right, so now we have sent message. Let's create an edge for receiving messages. We'll go from message to person this time, and we will say received message. And we will add the same attributes here. So we will add one of the from user, and that is a string. And we will also add one for read time, and that is a date time. Sorry, now we can see which user this message came from, and we can also tell what time our recipient read it at. And this will also be a directed edge because the message is being received by the user. So there's some directionality in that interaction. So we can go ahead and add that. And then lastly, we want to keep track of our likes. So the posts that specific users has liked. So we'll create another edge for that from person to post, and we will call this liked. And we'll want to make that directed because the person is liking the post. There's some directionality there. And for attributes, we will just add in, I believe we have a like time, and that is a date time. Great, so now we've created our basic schema. The next step here is to take it just from this interface and actually load this schema into our graph. So we do that with this publish schema button. And if I click that, we can see that it is changing our graph schema. And in a second, we will be able to see this schema reflected. So there we go. We can see that our schema is updated. And now if we head into our map data to graph tab, there we can see our schema again. This map data to graph tab is where you're going to map your data. The first things we'll want to do is upload some data. So I provided a couple CSV files for you to use with this sample. So I'm going to grab those now. So I have a few here. So we'll grab, I believe we can grab all of them at once. And those will get uploaded to our server. So what we can do is we can click on each one of those CSVs and we can get a basic overview of what we have. So one thing that we will see here is that our headers are appearing in our rows and we don't have any headers registering up here. So what we can do is we can just select has header, and now it'll just take the first row of our CSV and that will be our header. Here you could select any of the options that you need if you have any differently formatted CSVs. Mine are standard with a comma as a delimiter, standard Unix line endings, and no enclosing characters. So I can go ahead and select add for this. So now what this will do is this will take my user CSV and this will give me a little note that I can use to connect to my actual data. So let's take a look at how we do that. If we go up here, we'll select our map data file to vertex or edge. We'll select our data file, and then we'll select our person. And here is where we can start doing some of the fun connections. So we can see that all of the columns from our CSV file, ID, email, username, name, and join date, and we can see all of the attributes from our node. So these directly link up here. So if I select ID and then I select ID, we can link those together. Email, username, and so on. So essentially now I have linked our users file to our person node, and we can see that just by clicking on this line here. As we link in more, so as we bring in some more of our data, so let's now bring in posts. Once again, we'll have to select has header, and we have quotes encasing some of our fields here. So we've just added that, and now we can see that we have all of our content and our data. So if we select add, now One thing that you may notice about this post CSV is that it has some content about these hashtags in it. And as you recall from our schema, we don't store hashtag information on the post node itself. That's its own node. So let's take a look at how we can connect one data file to multiple different nodes, and even how we can do things a little bit easier through edges. So first, we'll map this to our posts. This will be relatively simple. ID to ID, content to content, posted date to posted date, and deleted is deleted. So that was easy. Next, what we'll want to do is map our tags. One of them is right, and one of them won't give us the results that we're looking for. So the first thing you might think is just to take posts, map that to hashtag, and then we can take these hashtags and we can map each one of them out to our tags. This isn't going to work the way that we expect. What this will do is it will create a hashtag node for each one of our hashtags, but we don't have anything that relates that hashtag node back to the post that has the hashtags. Because as you'll recall, our post node does not have any fields for storing that hashtag information. So instead of creating this linkage between our post CSV and our hashtag node, what we'll instead do is we'll map it to our edge. And what that allows us to do is look at what we have here. So our post starting vertex, we'll link that to the ID of our post, and then our hashtag will link that to the ID of our hashtag. So what this will do is it will take each one of our posts, it will load in the data into our post nodes, and it will create a vertex for each one of those entries in our CSV file. And then also what it's going to do is it's going to attempt to create an edge from each one of those vertices that it created to any hashtags that it might contain. But you'll notice here that we're not tying this data file to the hashtags themselves. We're just tying it to an edge. Edges have to point to a vertex. So if that vertex does not exist, if we go to say, create a vertex for the hashtag compatible, and we don't have a vertex for compatible, that vertex will be created so that the edge can point to it. If we point a file to an edge cannot exist without a vertex on each end. So therefore, if either or both vertices do not exist, they will be created. So if I were to delete the connection here between post.csv and our posts, so we were just loading in from this edge line here, then what would end up happening is we would create a post with our ID, as well as a hashtag with our ID, and an edge connecting them. Because this isn't linked back to our actual post, we don't get any of our attribute data. See, all that we're mapping here is the ID of our post to the name of our hashtag. So we would end up creating a blank post with an ID, but all default values for each one of its attributes, and a hashtag much the same with a set ID coming from our CSV file and blank attributes. Since our hashtag doesn't have any attributes, that would be indistinguishable from just linking it to the edge, which is why we can get away with doing that. Something to note here is that in our CSV, we have 4 different fields for hashtags, yet we only have 1 field for hashtag on our edges. So something that we'll need to do here is just create multiple mappings, because we can only map one of these per linkage here. So what we'll do is we'll just take our first one, we'll map that, and then again we'll just create a new mapping from our CSV file to our edge, and we'll just link each one of these as we did before, except for our separate hashtags. So there we had one for hashtag 2, let's do hashtag 3, and once again we'll just create that mapping for hashtag 4. So there we go. Now when we load in our post.csv, we will get posts as well as edges, connecting them to the hashtags that those posts contain. Next, let's link up our messages. So we'll just grab our messages CSV, make sure we have has header selected, and we have quotes for our enclosing character for some of our texts. So now we'll add that. Can place it over here. And let's start making some connections. So we will need to tie this to our messages node, because we have some attributes of the message that we need to fill out. ID1. So here's another interesting tool that we can use that's helpful if you create your nodes with the same headers as your CSV file. So over here, we can select the auto mapping button. And what that will do is match any of our column names to our attribute names between our CSV and our node. So there, that automatically made those connections for us, and that's great. Now let's create our edges. Our messages have both a sent and received edge. So we'll go from our source ID of the message. So that is our message ID, and our target attribute. So this one is our received message. So that is to user. And our from user is that one. And our read time is read time. So there we go. So we created that. And now let's just create the mapping for sent message. So that will be very similar. Our message ID goes to our target, our message. Our from person comes from our from person. Our to person goes to our to person. And the sent time goes to the sent time. So now our messages and message edges are mapped. So when we were adding our posts, I forgot to add a mapping to the edge here. So let's just create that now. Post, posted, and we'll link the ID of the post to the ID of our target post vertex, and the by user to our source vertex. So the user who created the post is the user who we're going to link that to, and then the posted date time. So there we go. And lastly, we just have our likes to add in. So we'll go to likes, has header, and we'll add that one in. And we can see here that that links our person, our source vertex, liked post to liked post, and the date time that they liked it at. So once we have our mapping all set up like it is now, all of our files are set, we can publish our data mapping to our server. So this will take approximately 17 seconds. And once that's done, we'll be able to begin actually loading our data. So there it goes. Data mapping is updated. So we'll head over to our next tab now, load data. So we see basically the same view that we had with our mapping data, and we can click on each one of these files now, and we can see we would have some information about it had we loaded it before. And using these buttons up here, we can switch between our graph statistics, which will show us our total number of vertices and edges of each type, and a little graph here that'll show that over time. We currently have 0 because we haven't clicked the big play button yet to start loading. And then we can have our data specific statistics here if we just click on this tab. So once we do click play to load the files, we'll see the current status of our loading job, currently not started. It's percentage of completion, 0% because we haven't started it, how much data we've loaded, the speed that we loaded it at, the average speed, and a few other things as well. So what we can do is let's go ahead and load our data. So if we have nothing selected and we click start resume loading, that will load all of our data sources. If we select one specific data source and then select start loading, it will just load that one data source. So I'm just going to go ahead and load everything at once. So we can see here, we are verifying what we are loading and what it is mapped to. And we will just confirm that and click continue. So if we watch this graph here in the bottom right there, we'll see that it will start to accumulate some vertices as our loads go through. And there we are. We've finished loading our data. That was pretty quick. And we can see that our graph is still updating, but our total counts up here will reflect the number of vertices and edges that we have created. So there we go. Now, let's get to the fun part. Let's see what some of our data looks like. So if we click the Explore Graph tab here, we actually have a few sub-tabs that we can go through. I'm going to start just with the Search Vertices by ID, and we can go through things after that. So what this allows you to do is grab a subset of random vertices from your graph, so you can just start poking around, or if you know a vertex ID, you can grab that vertex specifically. So I want to get 5 random people from our graph. So 5 is our default number, but otherwise you could enter in any number you wanted here. Nothing preventing you from doing that. And I selected I only want people. You could additionally filter to find people with only certain attributes or attributes of certain values. But for this, I'm just going to grab any of our random people. So here we can see we selected 5 people. And if we hover over them, we can see information about each person, their attributes of each vertex. Now, here's where things get pretty cool. So we can take our person, and if we double click on them, that will expand out any edges connected to that person. It's got a little bit of messy, but we can reset our graph by just selecting this little selector down here. There are a couple different layouts. Generally, force is your best one, but you can play around with the different layouts to see what situations they might each be useful in. So here we can see that this user has posted and liked a bunch of messages, and we can see each one of those messages here. If we expand one of our messages, we'll see that we can see who that message was sent to. So this is user ID 1 from user ID 9. And if we can find a post here, so posted. So we'll remember that our posts have hashtags. So if we double click on this post, we can see all the users that liked it, as well as the hashtags that post had. And let's just reset our view again so you can see a little bit of how this breaks out and makes more sense. So there, double clicking on the vertices, as you'll see, that expands out all of the edges from it. But sometimes you're only looking to traverse a certain type of edges. So that's where expands from vertices tab will come in. What we want to do here, we'll uncheck our all for now, and we'll find another one of our posts. So here we have a post posted. So we'll select that. And what we want to do is I want to expand out all of the tags, has tag. So I will select my has tag edge type. And what we can do here is I would select hashtag as my edge type because that's what hashtag goes to. But because hashtag only goes to the hashtag edge type, I can also just be lazy and select all here and click expand. And here we'll see that we've just expanded out the 3 hashtags that we have and not any of the people who liked it. So if we were to click on it again just to demonstrate, and I were to select liked and expand, now we get the group of users, the 4 users who have liked that post. Let's just reset our layout here. So here we can start to see some of the cool stuff about Graph. So here we have posts posted by this one user here, with a bit more information about them. And we can see that this user here has actually liked both of these posts. So now already we're starting to see a connection between these 2 separate posts and some other users within our graph. So let's see if this user has liked any of the other posts that user number 9 has made over here. So once again, we'll expand throughout the liked edge, and there we go. We do get some more posts, and there are a couple more that are shared from user 9. So once again, we'll reset our view, and here we can see some of the cool connections that we're building out here. So what we found here, though, is technically a path. We have a path from user 9 through these posts over to user number 44. And we found that just by clicking around. But if we wanted to find paths between 2 people, there'd be a lot of clicking, a lot of random luck there. So we can use some of our path finding algorithms to do that for us. So let's see if we can find any paths between user 28 and user 9 over here. So I want to go from person, vertex ID 9, to person, vertex ID 28, and I want to find paths. So here we go. Oh, no paths, it looks like. Going through vertex types. That's why. So make sure to select all here just so we can include any paths that there might be, or if you're looking only for a certain path through a certain edge type or vertex type, then you can filter by doing that. So now let's try that again. So there we go. So here we can see that we have a post that user 9 liked, and user 28 also liked that same post here. And by coincidence, user 44 also has liked that post. So that one just shows the one shortest path. We can show all shortest paths. So if we run that again, we will see that there are a couple more edges as well as another message that have appeared. So let's reset our graph layout one more time. And here's our user 28. Here's their connections to user 44. So once again, we have a few more posts that overlap there, and all these connections back to user 9. And then we can show all paths, which will not only show paths of the shortest length, so just here we have a 2-hop path, so we are traversing 2 edges and 1 node in order to get back to our vertices. So we have 1 hop here and a 2nd hop to this node. So show all paths will find any hops, and this may be a lot of hops because it could go, yeah, there we go. So what this could be is this user 28 liked a post by user 55, who liked a post by user 13, who sent a message to user 9, and that could be one of our paths. So that's just an extremely long path. It is helpful if you do want to see it, and even though we can't display it here, if you were to make a request or a query to your graph, you would be able to return all of those paths, even if we don't have the capability to display it graphically through our interface. Some of these other subtabs are a bit more advanced, and I will go into those at a later point in time, but these top 3 are your most useful for sort of exploring your graph and trying to figure out what is available to you.